This slide shows a typical IT organizational structure, which helps define how roles, responsibilities, and authority are divided within the IT function. A well-designed structure is essential for maintaining effective controls, smooth operations, and especially segregation of duties, or SOD, to prevent errors, misuse, or fraud. At the top of the structure is the Chief Information Officer, CIO, or IT Director, who oversees all IT activities and ensures that technology supports the organization's goals. Reporting to the CIO are key managers in charge of risk management, applications development and support, data management, technical support, operations, security administration, and user support. Let's break these down. The applications team, made up of programmers, systems analysts, and quality assurance (QA) staff, focuses on developing and maintaining business software. The technical support team handles networks, servers, and systems administration. The operations team manages day-to-day system performance, backups, and batch processing. The security administrator ensures that system access is controlled and that users have the right permissions. The database administrator, DBA, maintains data storage, availability, and performance. The help desk or user support team assists users with technical issues and password resets. In summary, an effective IT organizational structure with clear responsibilities and segregation of duties builds trust, accountability, and control, helping ensure that IT operations remain secure, efficient, and aligned with business objectives. Segregation of duties, SOD, is a key control that prevents any one person from having too much control over critical business or IT processes. It ensures that no single individual can initiate, approve, and record a transaction without oversight. Segregation of duties ensures that no one person can perform multiple roles that could create a conflict of interest or a control weakness. It's about separating responsibilities so that one person's work is checked or balanced by another's. Here are some real-life examples of SOD conflicts. Example 1. A programmer who develops an application should not also have access to deploy code into production. If they do, they could insert unauthorized changes or bypass testing controls. The operations team should handle deployments separately. Example 2. A database administrator, DBA, should not act as a security administrator. If they control both database access and security rights, they could create fake accounts or change financial records without detection. Example 3. The help desk should not approve access to sensitive systems. While they can reset passwords, access approvals should come from the system owner or security team to prevent unauthorized system entry. Example 4. The operations manager should not be involved in application development or quality assurance testing. This ensures that production systems are only updated with properly reviewed and approved software. Example 5. A disaster recovery coordinator should not be the one performing daily backups. Their role is to verify that backups are completed, stored securely, and periodically tested, not to run them directly. Example 6. A systems administrator who maintains servers should not also approve user access for those systems. That function belongs to the security administrator. In practice, these separations reduce the risk of data tampering, fraud, and unauthorized access. For example, in a bank or insurance company, if one person can both create new accounts and approve transactions, they could easily hide fraudulent activity. Proper segregation ensures that no single individual can compromise system integrity. SOD also acts as a deterrent. When people know that tasks are cross-checked, the likelihood of fraudulent activity drops significantly. In short, SOD ensures checks and balances, strengthens accountability, and protects the organization from both mistakes and malicious acts. When performing an IT governance review, an information system auditor must pay close attention to warning signs that show weaknesses in how IT is being managed. Some common IT governance problems include Excessive costs or budget overruns, showing poor cost control or planning. Late projects, which may mean unrealistic timelines or lack of proper project management. High staff turnover or inexperienced personnel, which weakens continuity and institutional knowledge. Frequent hardware or software errors and backlogs of user requests, showing inadequate system maintenance or resource shortages. Slow system performance, aborted or suspended projects, or a lack of training and succession planning, all of which point to weak governance structures and poor resource management. Example: in a bank or insurance company, if projects are always delayed and IT staff keep leaving, it could mean governance committees are not reviewing performance or approving resources effectively. To assess governance maturity, the information system auditor should review key documents such as IT strategies, plans, and budgets to check alignment with business goals, security policies, organizational charts, and job descriptions to ensure roles and accountability are clearly defined, steering committee reports and change management procedures to confirm there is oversight of IT projects and system changes, HR and QA manuals to evaluate staff competency and quality control processes. Finally, the auditor must determine two key things: whether these documents were created and approved by management as intended, whether they are current, accurate, and regularly updated. If they're outdated or poorly maintained, it's a sign that IT governance is reactive, not proactive, which exposes the organization to operational, compliance, and security risks.